Hello. All right, so last thing we need to think about is solving equations if we have things like cosine of 2x. We could think about using an identity, but this is pretty simple, right? So let's see if we can solve this. So just like we did before, I'm going to ignore the problem and say, let's let 2x equal alpha. Okay, so I'm just going to say, okay, well, cosine of alpha equals 1/2. That's pretty simple. I can solve that doing that exactly. So let's just remember cosine equals 1/2. I'm expecting two values, right? My first value, cosine of pi thirds. So alpha is going to equal pi thirds, right? And over the whole line, it's going to be, so even though this says 0 to 2 pi, when I'm masking something like this, when I'm using a substitution, I'm going to always write plus 2 pi k. Okay, so that's my first solution. What's my second solution here? There's symmetry, so this is going to be 5 pi thirds, right? 2 pi minus pi thirds. So my other one is going to be 2 pi thirds, or sorry, 5 pi thirds plus 2 pi times k. Those are my two solutions. All right, now to make things more complicated, I'm going to say, well, instead of alpha, I'm going to have 2x equals pi thirds plus 2 pi times k. And over here, I'm going to have 2x equals 5 pi thirds plus 2 pi times k. Right? Okay, now I'm going to solve for x. So I'm going to divide everything, this, and this, by 2. So I'm going to get x equals pi sixths plus pi times k. Right? I divided each of these terms by 2. And I'll do the same thing over here. So I'll get 5 pi sixths plus pi times k. So these are all my possible solutions. And now my question is, which solutions are in that interval from 0 to 2 pi? Okay, so I can just start listing them. So pi sixth definitely is. And if k is 1, that's going to be 7 pi sixths. If k is 2, if I add 6 again, I get 13 pi sixths. Is that within 0 to 2 pi? No. So that one's not there. So those are my two solutions over here. And here I can list, okay, 5 pi sixths, definitely in that right interval. If I add pi, I'll get 11 pi sixths. That works. If I add another pi, I'll get 17 pi sixths. That's going to be too big. So those are my solutions, those 4 values. Okay, so what did we do here? We made a substitution to make things easier for ourselves. We solved this simple equation, and we said, okay, the general solution is this. It's really important on these that you remember at that first step to add on plus 2 pi k. Okay? Then we substituted this back in for our alpha and divided through by 2, or we do whatever we needed to do to just get x here. So this is going to be the general form for all our possible solutions. And then we said, okay, which of these solutions are going to be in our original interval? Okay. So let's do another example like this. Let's try this one. So sine of x over 2 equals square root of 3 over 2. So again, we've got sort of this complication that the thing we're taking the trig function of is not nice. It's not just x or theta or something. So I'm going to say let alpha equal x over 2. All right, so now I'll make this nice again. Sine of alpha equals square root of 3 over 2. All right, so our sine function looks like this. Square root of 3 over 2, we're going to get one value here and one value here, right? Okay, so alpha equals, our first value is pi thirds again, right? I guess that was the answer for the last one. Pi thirds plus 2 pi times k. And what's this value here? Well, we'll use the symmetry from pi. If this is pi thirds, this is going to be 2 pi thirds. So alpha equals 2 pi thirds plus 2 pi times k. All right, Time to face reality, and I'm going to plug x over 2 back in for alpha. And now I will add or multiply 2. I'm going to solve for x, right? So I'll multiply all of these terms by 2. So x equals 2 pi thirds plus 4 pi times k. You see why it's important that we add this 2 pi k at the very beginning, because wacky stuff, unpredictable things will happen to it as we solve our problem for x. Okay, and we don't want to lose that. So here I'm going to have 4 pi thirds plus 4 pi times k, right? Okay, so now we have to say which of our values are going to fall in this interval from 0 to 2 pi. Well, definitely 2 pi thirds. If I add 4 pi, if k is 1 and I add 4 pi to it, I'm going to be way outside this interval, right? So this is the only answer. And the same thing over here. If I add 4 pi k, it's going to bring me way outside of 2 pi. So these are my only solutions. Okay, so we use the same process in both problems. And depending on what the format of this x over 2 or 3 times x or whatever it might be, that will kind of transform the general form of the equation, the solutions that you get. And then you ask, okay, which of those solutions are in my original interval?